Welcome to session 7.2. In this session, we will focus on the auto manufacturer's methodology. The objective is to understand how the framework was applied to this sector context. We will briefly go through, first, the context and key challenges identified for the sector decarbonization. 2, the key indicators packages and their relative importance. 3, the basic data that needs to be collected to make it all possible. And 4, the learning points from application of this methodology to the pilot phase. The automobile manufacturer sector is central to the energy transition and the climate. According to IPCC estimates, the transport sector represents nearly 14% of all GHG emissions and is therefore a significant contributor to climate change. Of this 14%, 10% are related to road transport and 4% to other transport. A considerable part of the emissions connected to this sector is due to the use of personal vehicles for daily individual transportation. By car constitutes the dominant mode of passenger transport globally, and emissions from the use of light-duty vehicles need to be reduced by 58% between 2010 and 2015, which translates to a reduction of 76% in emission per kilometer driven. This is why the ACT methodology focuses on certain key factors such as the efficiency of thermal engines, as well as any other technological initiatives to reduce emission due to the use phase. The main indicators used there is the gram CO2 per kilometer. This will come from a series of changes the sector will need to see and implement from the reduction of vehicle emission by changing to alternative vehicles like electric or hydrogen cars, shifting passenger journey away from personal car travel and working to enhance modal shifts and integration with public transport, to the role of electric vehicle as storage of renewable energy providing services to the electric grid, to the incorporation of circular economy principle into the car manufacturing life cycle, to the challenges of how to promote the sales of advanced vehicle sales and other business model changes like working with complex and highly integrated supply chain for technology shift, benefiting of car sharing, autonomous vehicles, and so on. The key indicator module for the auto sector are, as it would be expected, the performance of the sold product. What is at stake is the performance of the vehicle delivered and the related downstream emission, meaning the use phase. This module is therefore weighted at 35% of the overall performance score. An automobile manufacturer company has an impact on the whole of its value chain and has a share of responsibility for the use of the goods and services it markets. The emission related to the use of the marketed product can amount to the majority of emission during the life cycle of an automobile. A reduction of their impact can, for instance, be achieved thanks to more energy efficiency product, an engaged and controlled supply chain, or product using technology that emit low volumes of GHGs. Reduction target, and it's particular for the vehicle fleet produced, is the next module in terms of final weight, with 15% followed by intangible investment due to the importance of R&D in alternative vehicle technology, integrated with grids, autonomous vehicles, and so on. Because of the role of the supplier and customer engagement, they are also weighted in the final performance rating. Data collected for the auto sector performance assessment comprise, first, target in terms of passenger vehicles and light-duty vehicles. Data on the production of passenger vehicles and light-duty vehicles, number of years. Breakdown of sales per region and carbon intensity of these sales. Breakdown of sales per technology per class of vehicle. Second, R&D spending on climate change mitigation, for instance, internal combustion and hybrid engine, electric and hydrogen, infrastructures enabling the development of low-carbon transport. Third, existence of a test of the strategy in a scenario taking climate change into account. Fourth, GHG engagement action with suppliers and share of suppliers involved. Fifth, existence of programs promoting the sales of vehicles that emit less GHG. Here are the following key learnings from the application of the auto methodology to real companies. Emission reduction targets need to be defined at regular intervals and not just early or too far in the future. And it's very important that transition plan consider the midterm within 10 to 20 years, which is the period of faster change in the low-carbon transition. We need complete and as specific as possible data on the emission of the fleet of vehicles sold in past year. Without this information, it's challenging to calculate some of the indicators. If no data is available, use of secondary sources like public databases on vehicles sold and their emission might have to be used. Measurement and reporting of R&D spending in non-mature technologies is a challenging area and more work needs to be done in this area. Here we are going through some details on the key performance indicators and how they are used to set up a performance scoring. I start by presenting to you the full list of KPIs for the auto sectors. Please do not be afraid, we will just focus on one indicator, the Auto 4.2 related to the Lockheed fleet emission. For this indicator, we first look at sales and extrapolate their trend 5 years into the future. Then, we characterize the fleet in terms of efficiency and calculate a 5-year Lockheed emission budget, we call here A, and we calculate also a 2 degrees Lockheed emission budget by multiplying the same sale projection by a 2-degree vehicle efficiency pathway to obtain a 2-degree compatible sold vehicle carbon budget that we call here B. The indicator is the Lockheed ratio, meaning A divided by B. The indicator then needs to be transformed into a score. The rule applied here is if the ratio is below 100%, then the company sold vehicle performance is better than 2 degrees, and the company gets a score of 100%. But if the Lockheed ratio is higher than 1.5, then the performance is significantly worse than 2 degrees and the company gets a 0. If it is between 1 and 1.5, the company will get a proportional value between 1 and 0. So if the Lockheed ratio was 1.25, it would get 50% score, and this would finally be multiplied by the final weight of this indicator to the performance score, which is 7%. And so contribute with a value of 3.5% to the final performance score. And this way, by multiplying the indicator weight by the indicator scores, that you compute the final performance score. Here you can find a visual representation of the relevant module for the auto manufacturers. The indicators that compose them and their relative weight expressed as the width of the bar in this bar chart. The width of the bar represents its weight in the overall performance score. The colored area versus the entire area provides the basis for the final performance score, a weight average, which is expressed here as a number from 0 to 20.